Alright, in this video I'm going to remind you of the result we've covered about exponential functions and logarithmic functions, okay? So let's start with exponential functions. What's an exponential function? It's a function that is written like this, alright? A is called the base, alright? Base, and x is the exponent. Of course, you've known that for a while. We're going to assume that a is positive, and we're going to assume that x is a real number, okay? This assumption actually is very, very important. It's completely new. If you remember, we said in class we can't really define it rigorously in Algebra 2. We're going to assume it exists. Why we can't define it rigorously? Well, for example, we can't really give a meaning to something like that. Okay, what would that mean? It's difficult to, of course you can define it, but in Algebra 2 we can't approach the definition, okay? So we're going to assume that this type of functions exist. What we said about this function is we said a lot of things, but what you really need to know is two things. There's two types of functions. One for which the base is above 1, which is they are the most common type. And another type is a function for which the base is, well, I have to be careful, it's smaller than 1, but I'll still want to say positive, right? This is the assumption for any functions. Okay? So what do you need to know about them? You need to know that when the base is above 1, the function looks like that. Actually, let me change color here. Here we go. The function is increasing. Okay? And when the base is smaller than 1, the function is decreasing. Okay? These are the two important type of function, exponential functions. The only one, actually. Here we go, decreasing like that. Okay? I'm not going to write the property of this type of function. We wrote them in class. But you remember these are the fastest increasing function. Okay, nothing increases faster than an exponential. The thing I want you to do all the time is at least plot 2 points right here. That's the point when the input is 0, the output is always 1. So this is a point 0, 1. And then if the input is 1, well, the output is a to the 1 is a, so this is the point 1a. Now, if you're dealing with a nice base like 2 or 3, you can plot more points, and I would expect you to plot as many points as you can, but at least you should be plotting these two. Now here, we have the same point right here. If the input is 0, the output is still 1, okay? A to the 0 is 1. And then we don't look at x equals 1 right here because a is smaller than 1. For example, like if you take a equals 1/2, you know, we wouldn't plot a right here. This is not the point that we plot, you know, 1a. We usually don't plot this one. Usually what we do, when the base looks like that, we would plot the point for a equals -1. Then you have the point -1, 1 over a. Okay, why? Because in this case you would have like -1, and 1 over 1/2 is just 2. Okay, so it's a very nice point to plot. Okay, you have to look at it, but again, these are not the most common type of exponential function. So that's it, and then all the properties, you know, here I'll just write the first two, but again, we wrote them all in class. The domain for any of these type of functions, okay? The domain, of course, is right here. This is my domain, right? This is my new domain. This is what's new about it. The domain is the set of real numbers. Okay? Actually, let me use set notation or interval notation. Here's set notation, right? And here's interval notation. That's domain. The range, well, the range, as you can see, the range is everything above the x-axis, right? I don't have an output that is below the x-axis, and actually I don't even have an output equal to 0. Okay, 0 is not part of the range. So the range is all positive real numbers, okay? The reason for these two things, again, we can't explain. That is based on the definition you would have to give to an exponential. We just notice that graphically. There are other properties, limits at infinity. Here, let's write the limits. Actually, that's kind of important. For this type of functions, then you will have, so this is true for both, right? For this type of functions, what's the limit of a to the x as x approaches negative infinity, and what is the limit of a to the x as x approaches positive infinity? All right, well, let's look at it. If the input approaches negative infinity, the output is approaching 0, right? If I move to the left, if x moves to the left, y, look at the y's. The y's of all these points is getting closer and closer to 0. That's 0. And if the input moves to the right, if the input approaches plus infinity, where are the y's on the graph? Well, check it out. It goes up, 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 right? So the output approaches plus infinity. Here we go. And here, let's write that for this function right here. Limit of a to the x as x approaches negative infinity, and limit of a to the x as x approaches positive infinity equals, well, at negative infinity here it goes up, and at positive infinity it approaches 0. So basically they are switched, okay? And then there are all the properties, increasing, decreasing, asymptote and stuff like that. I'm not going to write them here. Check in your note, it should be all there. And the other thing we've done also with this graph is we graph shifted them, okay? So again, I'm not going to cover that right here. What else did we do with exponential function? Well, we've covered three more properties. We looked at, as an application of exponential function, we looked at compounded interest, okay? And we said, for example, if you invest an amount of money, the original amount, let's call that P, the interest rate, let's call that R. Be careful, it's in decimal, okay? Decimal. It's usually given in percent, don't forget to write in decimal. And let's compound that. I've explained in class what compounding is. Let's compound that n times a year. And if it's yearly, then n equals 1, okay? The formula in this case is, A of t, I'll tell you what that is, okay? It's the amount you have in your account, equals P times 1 plus R divided by n to the power of n times t, okay? This is the amount in account after t years, okay? And this is t. I'm sorry, of course it's t, it's written. This is in years, okay? This is in years. This is compounded n times a year. We've also looked at the case where it was compounded continuously, and we had another formula for that, okay? So if you compound all the time, compound it continuously, we had another formula for that. Okay, so the formula was A of t is going to be equal to P times ERT. Okay, A of t and t are the same thing. And here we go, we got, so what is this? What is E? Let's talk about it quickly. This is something, again, that should be in your note. E is an irrational number, just like pi. You can't write it as a fraction, okay? The way we approach E is by looking, one way to approach E is by looking at this function right here, defined for x positive, okay? And if you look at the graph of this function, this is something we do on the calculator, okay? We don't approach it with mathematical tools analytically. We don't have enough tools to do that. We just look at the graph on the calculator. The graph looks like this. The graph looks like this. And what you notice is that there seems to be too low. There seems to be an asymptote. Too low still. Here, let's start right here. There seems to be an asymptote. The output seems to be bounded upward. They don't go above a certain value, but they get closer and closer and closer to the value. Well, this value, by definition, oops, I've lost everything. Where's that? This value, by definition, right here, we call that E, and it's about 2.71. And there's a lot of digits there, okay? So basically, we set E as a limit, and I said in class I'd like you to know that, this limit. E, by definition, is a limit of the function, this function right here, as x approaches infinity, okay? And that is all for exponential function. So actually, I'm going to stop the first video right here, and then I will, in the second video, I will quickly review logarithmic functions, okay? Here we go.